Welcome, one and all. Thank you for joining us on this beautiful day. Let's get this show on the road. Thank you for everyone who's dialed in already. Another uber popular webinar. I think a lot of people think I make up these numbers, but I promise you I don't. 624 registrations for today's webinar. Last time I spoke. So thank you so much for all the amazing attention that you and your colleagues are giving this fundamental series. We've been blown away with how popular it is. And it is the fourth of the fundamental series. We're doing a total of 12 throughout the year. We've already done three of them already, which have been super popular. I think nearly 2,000 registrations across the first three sessions. So again, thanks to everyone for who's dialed into those already. If you missed them, and we get a lot of requests from people who have missed the individual webinars, all the recordings and the slides for each of the sessions are always made available on the oceanprotect.com.au/webinars website. There's obviously today's webinar, but we've got another, another 8 after today. So all the details on how to register for those are on that website, that oceanprotect.com.au/webinars website. Also, full disclosure, there's and thanks for everyone who's put in a bit of a QE in the chat. Thank you. Thank you, Alan Parkin from City of Moreton Bay. We've had so much tendencies from councils across Australia. It's been amazing. So I really appreciate that. But look, and I wanted to mention, like, given the popularity of the fundamental series in 2024, we're already planning for another Stormwater Fundamental series in 2025. So if you do have any ideas or suggestions or requests for topics that you'd like us or others to cover for next year's fundamental series, feel free to reach out to me directly or just drop it in the chat. But without further ado, I might just get stuck in. But just a reminder, and I can see people are still coming through the virtual turnstiles. We've just cracked 200, so welcome everyone who's dialed in. Just a reminder, yeah, as I mentioned before, the slides and recording from today will be made available. It generally takes a couple of days to put them on the website. But if you've got any CPD requests as well, and we get a lot of those, feel free to email that email address, inquiries@oceanprotect.com.au. And apologies if it might take some time. I think we're caught up now, but we did have a bit of a backlog of CPD requests. And just a reminder, if you do have any questions throughout today's, please put them in the Q&A panel. It makes it a lot easier for me to track. If you've got any comments, feel free to put it in the chat, but it makes it a lot easier for me to track and answer questions if you put them in the Q&A panel. Okay. Cool. Great. Let's get the show on the road, shall we? So there's a lot of content to cover. I'm going to try and cover it as best I can in the time available, hoping to keep it under about half an hour or thereabouts, maybe a bit more. But let's just dive straight into it. So this is what I'm basically looking to cover today, talking about the impacts of urban stormwater management, or traditional urban stormwater management, I should say. It's a bit of a lead into the next session, but I'll keep you in suspense in relation to that. But yeah, we're going to talk about key catchment changes associated with urban development, the associated changes to stormwater quality and quantity, and what that also means to waterway health. I'm also going to touch on the types and sources and impacts of what we call, I guess, the common stormwater pollutants, but I'm also going to touch on briefly emerging contaminants associated with urban stormwater in particular. But as per normal, if you've got any questions, feel free to chuck them in the Q&A, and we'll aim to get to them towards the end. But look, you've probably seen a graph like this 1,000 times if you've done any sort of an environmental type degree, but I think it's important to come back to first principles when talking about the impacts of urban stormwater management, because in a natural catchment, the catchment hydrology and the associated water quality and ecological health is very different. So in a forested environment, we have obviously rainfall, and we have a lot of evapotranspiration, a lot of infiltration, soaking of water into the ground, which makes its way very, very slowly typically into downstream waterways as base flow or groundwater recharge. And also in a forested catchment, we don't actually get much in the way of surface runoff. We need a lot of rainfall to generate any surface runoff in a forested environment, which is very different to urban areas. And I'll come to that very shortly. But obviously, depending on where you are in a catchment, the waterway will often be different. So in the upper reaches of the catchment, we have gullies and small creeks, etc. And towards the end of the catchment, we have obviously estuaries and marine environments, and they operate very differently. Smaller creeks with smaller catchments are obviously far more sensitive to any sort of change. But the downstream environments near estuaries, etc., have what we call tidal flushing, or essentially are a lot less susceptible or a lot less sensitive to land use change. To give you an idea, this is a bit of a, I guess, a model result infographic from my old employer, BMT WBM, back in the day. This is going back a few years now, which is, it basically shows a sediment plume coming from a large catchment in southeast Queensland and entering into the downstream bay environment. And you can see the brown, which is the sediment plume coming from the catchment. You can see the waterways, the upper waterways, obviously much more sensitive, that you get a spike of turbidity in this case, but the estuarine environment has what we call tidal flushing, so that the action of the the tide going up and down basically acts to flush a lot of that pollution out of the system, typically replacing that potentially contaminated water with cleaner water. I see a few hands up. If you've got any specific questions you'd like to ask or something you'd like to say, feel free to put it in the chat and I'll get to that, or put it in the Q&A as well. So diving straight into it, let's talk about urbanisation. So fundamentally, we've got a lot of people coming to Australia, and why not? It's a beautiful part of the world. But yeah, the population growth is pretty significant. What's that, about 1.5%, 2.5% per year? Obviously, COVID was a little bit of an exception, but yeah, we got a lot of people coming to Australia, particularly in certain parts of Australia. So where I'm based in southeast Queensland, yeah, a lot of people are coming to southeast Queensland. This is from the Southeast Queensland Regional Plan, just last year. So in 23 years, come 2046, there's going to be an additional 2.2 million people. Which is a staggering increase. That's over a third more people in southeast Queensland. Admittedly, it's a beautiful place to live, and I'd certainly encourage everyone to move here within reason. But it's not the only place in Australia with a lot of population growth. New South Wales, this is statistics from the Planning Department of New South Wales. And yeah, New South Wales had a lot of population growth, particularly in Western Sydney, which is, I think, one of the fastest, if not the fastest growing area in Australia. So, but that urbanisation, okay, it's happening. So what are the key catchment or land usage changes associated with that urbanisation? For me, these are the key ones: vegetation loss, increased imperviousness, increased hydraulic efficiency, and pollution. So these are some happy snaps from taken over the years. This is a top photo, shows basically land being cleared. This is out at Springfield Lakes, probably a decade or so ago now, at least. And that's basically being progressively built out with a whole bunch of roads, houses, etc., which obviously changes the dynamics of the catchment hydrology. And also something that's often forgotten about. Often we can't do much readily, or at least practically, when it comes to decreasing imperviousness. But certainly one of the things that we do see with urban environments, at least traditionally, is this increased hydraulic efficiency. So there's a real desire or objective to just get water, stormwater away as quickly and efficiently as possible. I'll come to that a little bit later. And also we get increased pollutant loads, higher concentrations of pollutants, but also pollutants that just wouldn't otherwise appear in a natural catchment. Very quickly on these impervious areas, yeah, the key ones are roofs, roads, driveways, etc. Particularly roads. Roads are a major part of the imperviousness of a catchment. You can see here, back in the day, even I think it's probably worse. Some areas have up to 70% of the impervious areas of an urban environment dedicated to just cars, basically. So we're a long way off flying cars, but in the meantime, we've got a massive issue with increased imperviousness. What does that actually mean, though, that increased imperviousness and vegetation loss? Fundamentally, from a hydrological perspective, and that's what we're here to talk about when it comes to stormwater. Yeah, we see reduced rainfall interception, we reduce runoff interception, reduced infiltration, so less water soaking into the ground, more runoff being generated. And generally, runoff is transported much more quicker and more intensely into our waterways. As a side note, this is a picture of me hugging a tree in the Amazon rainforest. Oh, what's that, 21 years ago now? But yeah, everyone should hug a tree every so often. But yeah, fundamentally, you don't need much rainfall in an urban environment to generate runoff. You generally need at least 25 mils or thereabouts to generate any surface runoff in a forested environment. But when it comes to an urban environment, you only need 1 or 2 millimeters to start generating runoff. So fundamentally, we see more volume and more frequent runoff events in an urbanized environment relative to a forested environment. So let's talk about that now. I'm keen to talk about water quantity now. So stormwater quantity. And very quickly talking about just the elements of the traditional stormwater management system. So fundamentally, traditionally, stormwater engineers have been all about just trying to get that stormwater away as quickly and efficiently as possible. Generally focused very much on flood protection. So protecting people and property from, big events, the Q100 events, the Q50, Q20, stuff that can cause some dramas. Cool comments. Loving all these comments coming through. Keep them coming. Another blast from the path. This is a photo of me back in 2002 in West Yorkshire. But fundamentally in Australia, we generally have what are considered, in inverted commas, separate stormwater and wastewater. So when our wastewater system or our sewage infrastructure is handling the toilets, the bathrooms, kitchen sinks, laundry, etc., and there's a separate set of pipes for stormwater runoff. And I use that term in inverted commas, separate, because there often there's this cross contamination. Often stormwater will discharge or leak or infiltrate into wastewater. Equally, wastewater can often go into stormwater. So whether it be through illegal connections or whatever, often they aren't necessarily separate as such. Bit different in other parts of the world, including the UK. So when I was in the UK as a sewage engineer back in the day, one of my jobs was to investigate sewage flooding into people's houses. So in the UK, they often have cellars and other sort of low-lying buildings. And because they've got this combined system, if the sewage has got nowhere to go in a storm event, it'll rise up into people's properties, which is a whole bunch of drama. And that's a story for another day. But yeah, so typical elements of a traditional storm management system are really just about getting that water away as quickly as possible. So curbside channels and pits, pipes, which I know Sean Quilty has done 3 webinars on as part of this fundamental series already. And then off-sea channels, whether they're overland flows or big sort of concrete drains, whatever, and often detention basins to try and handle or detain those big infrequent Q50, Q100 storm events. So fundamentally, most of the elements are about just getting the water away from people and property as quickly and efficiently as possible. So again, the hydrological impacts of that are more or less the same as just getting rid of trees and putting down imperviousness. Reduced rainfall, runoff and interception, reduced infiltration, and again, water's just got a lot more energy going into our waterways. And you've probably seen a graph like this before. I won't dwell on it too much, but you've got a relationship here between flow and time. After a rainfall event, you might get a sort of a peak of the flow here. And this might be, say, before urbanisation. But when you actually urbanize a catchment, it very much changes the hydrograph for any particular rainfall event. So generally, you get a higher peak flow rate. So the peak here, for example, is much higher than the peak for that pre-urbanisation. Also, the hydrograph peak is actually quicker, actually occurs sooner. So you can see here the time it takes to get to this peak is for the post-urbanization is much faster because of that increased imperviousness, hydraulic efficiency, etc. And also the volume of runoff. So the volume of flow, the area underneath the graph is obviously bigger post-urbanization. And you imagine that sort of is the case every time it rains often. So again, decreased time to peak flow, increased flow rate, and also increased flow volume, which obviously has big impacts to the health of our waterways. This is a little bit of a different graph. Often stormwater engineers wouldn't have seen something like this, but this shows basically a hypothetical relationship. It's basically considering just one catchment, just two hypothetical waterways. One, assuming it was forested, so pre-urbanization, another relationship showing post-urbanization. So you've got rainfall on this axis. So these little black blobs here, they're rainfall events. So big rainfall event, little rainfall event. The flow on this axis there's this graph here for the forested stream, and on this axis, the hypothetical one is for the urban stream as well. So key differences here kind of highlight the changes associated with catchment hydrology associated with urbanization. So first up, you can see for the urbanized stream, the peak flow is higher. Again, probably the volume of that runoff is higher as well. It's quicker to that peak, but also the forested stream has a much in this case, higher base flow than the urban stream. And you might be thinking, why is that the case? Well, again, getting back to that first principles diagram I showed before, because of that lack of infiltration, that lack of water soaking into the ground, because of that increased imperviousness associated with urbanization, we do generally see a lower base flow in urban waterways. Sometimes, this is going to sound counterintuitive, sometimes the urban stream can actually be higher in terms of the base flow, but that's often due to leaky water pipes. Very easy thing to check. You can just take a sample of the base flow and test it for chlorine, typically. But generally speaking, an urban waterway has much lower base flow than a forested stream. Also, you can see here, you can see a change in the flow more or less every time it rains. You need for an urban stream, you need a lot of rainfall to sort of see any sort of change in the flow characteristics in a forested stream. Again, it's because of that increased imperviousness, hydraulic efficiency. Every time it's raining, it's changing or basically resulting in more flow going into the urban waterway. And obviously that potentially might cause erosion and scour, more flow energy, et cetera. But also every time it's generating surface runoff, it's carrying more and more pollution into that waterway, which again has impacts, which I'll come to shortly as well. So again, key changes here. Illustrated, basically, with urbanization, you get decreased time to peak flow, increased peak flow rate, increased flow volume, and increased runoff frequency, particularly for the smaller, more frequent rainfall events that previously caused no runoff in a forested environment. And that's, for me, that is key. I'll get to that shortly. This is a bit of a complicated graph. It basically just shows that the impact to peak flow rates is far more severe when it comes to imperviousness for the smaller, more frequent rainfall events. For the big events, the Q100s, the Q50s, yeah, there is a change between impervious versus non-impervious, but the bigger change between flow rates is observed in the smaller, more frequent rainfall events. Same thing for hydraulic efficiency here. This is straight out of a Tony Wong reference from 24 years ago, showing my age. Basically, again, shows the impact associated with hydraulic efficiency is far more pronounced for the smaller, more frequent rainfall events. And obviously, that's something we could potentially look to mitigate. So that's water quantity, crash course in water quality now. So stormwater becomes polluted, basically. There's a bunch of processes, but fundamentally you get a buildup of pollution, and when rain falls, it often just washes that pollution off. There's a whole bunch of things going on here, but you can get deposition from the atmosphere. You can get just obviously pollution being generated or blown by wind, or people accidentally or deliberately putting the pollution there. And there's a whole bunch of variables there. And obviously, again, on wash off, yeah, rain falls, it can often wash contamination even out of the atmosphere, but also it can move or wash off that pollution from ground surfaces into downstream waterways, or into the stormwater at least. And we often try and simplify this with our fancy modeling packages. It's very much a simplification, but you generally see some sort of first flush happening. So the higher pollutant concentrations being generated in the early stages of a flow event or a rainfall event. Now, again, we try and simplify that with our models by using event mean concentrations, whatever, but fundamentally, we do see a first flush effect, at least on a small scale. When you look at a catchment or a waterway, even at a large scale, often first flushes from one part of the catchment will be diluted by other flow from other parts of the catchment. But certainly, the closer you are to the source or the source of pollution being generated, you do see this sort of increase in pollutant concentrations in the early stages of a storm event, which again, for me, highlights the fact that we really should be targeting pollution treatment or mitigation at the source as a priority, which is often forgotten about. But yeah, look, talking about forested catchments again, look, forested catchments, the waterways are generally pretty healthy. So most of any pollution or contamination that might be generated or accumulated in the forest is generally retained within the forest. So water quality is actually in forested waterways is generally pretty good. Generally low levels of contamination and high levels of dissolved oxygen. Urbanisation, though, very much changes that. We see an increase in the amount of contamination. Not to say forested catchments aren't free of contamination, but we certainly see an increase in contamination generally in urbanized environments, but also urban development or just basically people and property in general. We introduce a whole bunch of potentially toxic contaminants that just wouldn't appear in a forested environment, like Big Mac wrappers and single-use bottles and cigarette butts. No koalas are hanging in the eucalyptus trees, smoking any durries. But yeah, certainly urbanisation changes that. These are the key pollutants that we generally talk about when it comes to urban stormwater. So sediments, nutrients, heavy metals, bacteria, litter, etc. And I'm gonna touch on those briefly now, but I'm going to talk about emerging contaminants as well. So sediments, I'm just talking about dirt basically, and generally key sources are erosion and land degradation, and you can get that in even fully developed catchments. Obviously, the worst by far, by a long way, is in the construction phase, and that's still a massive issue in across Australia. These are some results you can see, from recent Healthy Land and Waterway Healthy Land and Water study from 2022, just 2 years ago. 40% of construction sites are still non-compliant, i.e. operating illegally when it comes to just basic erosion sediment control practices. And as a result, we see a lot of mud going into our waterways. But even like I said, even in an urban environment, you still get a lot of solids, particulate matter being generated and high concentrations in urban stormwater runoff. Nutrients, generally we're talking about nitrogen and phosphorus, and this comes from a whole bunch of sources. Again, dirt, so you get a lot of particulate bound nutrients in addition to dissolved. But yeah, roads, sewage, detergents, fertilizers, etc. They're all key sources of nutrients. Rainfall is a key source of nitrogen as well. Why? Because there's a lot of nitrogen in our atmosphere. Now that nitrogen, if it comes to the ground through rainfall, acting like a big scrubber, yeah, in a forested environment, that nitrogen will be taken up by the processes in the forest, which is great. But in an urban environment, that nitrogen can often just wash straight into our creeks and rivers, etc. And that connection, that direct connection between hard stand area and waterway is when it becomes a real key pollutant of concern. Heavy metals, yeah, cadmium, chromium, nickel, lead, zinc, etc. Again, the typical sources. Generally, when you've got dirt, you've got other attached pollutants, including heavy metals. Obviously, roads and roofs are a key source as well, zinc roofs, etc. And then you've got bacteria, so basically poo, whether it's from animals like domestic pets or whatever, or just birds, etc. And often, like I said before, you often have sewage somehow infiltrating or leaking or connecting into stormwater as well. So yeah, and then you've got gross pollutants. So generally the gross pollutant definition includes litter and vegetation, but anything bigger than about 5 millimeters, like a cigarette butt, This is a photo from a recent cleanup I was involved with. Just a handful of volunteers removed about 15,000 cigarette butts from from Surface Paradise in about an hour. Staggering. I didn't even think anyone smoked anymore, but yeah, they certainly are. Yeah, obviously key sources of gross pollutants are humans and obviously vegetation. And to give you an idea of what we pull out of Ocean Protect, say, devices, these are some photos of gully pit baskets, so integrated into roadside gully pits. And you can see what we pull out, a whole bunch of single-use plastics, manky sediments full of microplastics and heavy metals and hydrocarbons and all that sort of stuff. It's pretty gross, but this is the reality of what we see in stormwater treatment assets. So yeah, not great, but pretty stoked that these devices are there in the first place. This gives you an idea of what we pulled out of. You might have seen this before. 8 gully pit baskets. We had 8 gully pit baskets. 8 in a very stock standard Western Sydney street for 5 months, and this is what we pulled out of them. Staggering, staggering. Single-use plastics, you name it, whole bunch of manky sediment, whatever. Not good enough. So yeah, long story short, stormwater is really polluted. Then you got gross pollutant traps, like the big end-of-line gross pollutant traps are like this. I've got lots of photos like this showing what we pull out of various devices. It's pretty gross, but yeah, stormwater fundamentally is polluted. It's a hazard. This gives you an idea of what we pull out of. This is a study from council in Western Sydney. They looked at what they were pulling out of about 158 of their GPTs over a nearly 3-year period. And yeah, roughly about 17% is litter. Whole bunch of organics and a lot of sediment. And again, that sediment and organics does contain a lot of attached contamination as well, hydrocarbons, heavy metals, etc., microplastics. Give you an idea again, snapshot. These are some clean storm filter cartridges. This is kind of what they look like on the right hand side. What they look like after being in the ground for 2 or 3 years. It's gross. This is what is in stormwater. These filters are filtering stormwater. And what we pick up out of these devices is gross. And you do not want to have this in your downstream waterway, ideally. So yeah, again, we got lots of photo of this sort of stuff. These are some clean jellyfish units. These are like a membrane cartridge filtration system going in, brand new. And this is kind of off what they look like when they're pulled out of the ground. It's gross. Yeah, so stormwater is really, can be really high in pollutant concentrations. It's gross. Yeah. Got lots of photos like this. Fundamentally, stormwater is polluted and you don't want it in your waterways. We have, eWater's got a fancy modeling software, which I guess many of you guys are familiar with, that actually models these common pollutants, at least in terms of TSS, TNTP, and gross pollutants. It's not ideal, but it's probably the best tool that we have available to do that. I'm going to touch very quickly on emerging contaminants, and this is probably a session in itself, but these are for me, these are probably 2 contaminants that don't get nearly enough attention, at least from the stormwater industry. Microplastics. Microplastics are present in stormwater at very high concentrations, and the science is growing, but it's very new. But it's pretty clear microplastics are causing human health harm. There was the study in 2019, just 5 years ago, found it in poo, and then they found it in the placentas of babies, and then they found it in blood and all our vital organs, including our brain. And now the more recent science shows that it's causing human health dramas. So increased cancer growth and also increased risk of heart disease and stroke. So fundamentally, stormwater is, particularly in relation to microplastics, it is a human health problem. And one of the key microplastics that we don't get enough attention on is tires. It's according to the IUCN, it's the #1 source of primary microplastics in our oceans, and it's highly toxic. There's a whole bunch of studies that demonstrate that it kills, for example, coho salmon in Phuket Sound en masse every time it rains. And it's certainly present in Australian waterways. That's a particular chemical called 6-PPD, which breaks down into 6-PB to quinone. And again, I can talk about that all day, but I'll move quickly on. But long story short, these sort of pollutants don't get nearly enough attention. particularly this one. I'm always staggered when I talk to stormwater engineers about PFAS, and most don't know what PFAS is. It's not a criticism. It's just it's a massive problem, and it doesn't get nearly enough attention. If you're not familiar with it, it's found in Teflon pans, firefighting foams, fire retarding clothing, etc. Long story short, it's pretty much everywhere. It's a very difficult contaminant to remove. Full disclosure, Ocean Protect do have a device that removes it, but um, it's a massive problem worldwide, and it's shown to accumulate or bioaccumulate, particularly accumulating to your fatty tissue or fatty organs, and it's considered a potential carcinogen. So it's a very, very high priority for environmental regulators. And it's got a lot of media attention. Literally 2 or 3 days ago, Stan released their How to Poison the Planet documentary, which talks about PFAS. There's books, there's movies starring Mark Ruffalo, and a whole bunch of lawsuits, media reports, etc. Australian Story did a story on it on the Williamstown community suffering from the ill effects of PFAS. But it's a major problem, and it's in stormwater. So yeah, look, major concern. And it's certainly a major concern for the Department of Defence, because I've got a whole bunch of sites around Australia that are known hotspots for PFAS. And it's not just an Australian problem; it's everywhere, including the States. This is a map of various PFAS problem sites in the US, i.e., that's lots of them. And there's a bunch of guidance around this as well from Australian authorities, but also overseas as well. So getting back to just pollution in general. So yeah, increased pollutant loads in the catchment from urbanisation, but also with urbanisation, we get increased flows to from the catchment to our waterways, which subsequently means we get more pollution going into our waterways. Pretty simple equation, but what are the impacts? Let's talk about them now. So generally, if I look at just the general categories of impacts, it's basically 4 things: flooding, channel form, water quality, and the subsequent ecological impacts. So let's talk about flooding first. Generally, I'd suggest most of the time we've got this covered. So we've for a long time, urban development has had to achieve or demonstrate, excuse me, a no worsening in peak flow rates for large rainfall events. Q50s, Q100s generally, sometimes Q20s, Q10s, etc., Q5. And generally that means some sort of detention basin or some sort of detention is required. So this is a typical development one I worked on many years ago in Waterford. And long story short, a whole bunch of flow would drain to in this case, a big space where we basically put in a detention basin to slow the big flows down, the Q20s, Q50s, Q100s, to make sure that properties downstream of the development wouldn't suffer any increased frequency or severity of flooding. So yeah, most developments need some sort of end of pipe flood detention, focusing on the big events, the big infrequent rainfall events, but almost no consideration for smaller, more frequent rainfall events. Channel form impacts. So when I talk about channel form, I'm talking about the shape of the channel, the waterway, the gully, etc. And that'll change in terms of its width, its depth, etc., in response to a whole bunch of factors: sediment supply, size and frequency, and flow. So fundamentally, channels, unless it's constrained by bedrock or whatever, they change. But they change with these things, that urbanisation changes. So with urbanisation, we get increased peak flow, as I've talked about before, increased peak flow, increased volume of runoff, and particularly increased frequency of flows, and also obviously increased sediment supply. So urbanisation has these impacts, and the channel form is obviously dependent on these changes. So we do see changes in channel form, because, at least historically, there's been almost no attention given to managing these, or at least mitigating these small, frequent rainfall events, which is a mistake. So as a result, we do see changes to channel form, increased erosion, scour, etc., wider, deeper channels, and reduced riparian vegetation being present. So this photo, for example, is directly downstream of a detention basin. So that concrete apron you can see is the, I guess, the apron of the outlet of a detention basin, detaining Q50, Q100 events, big infrequent rainfall events, which is great. doing nothing for smaller events. And as a result, you can see the erosion here. So this channel itself, to give you some context, is about probably 10 to 15 meters wide. And that erosion you can see on the right-hand side there and on the left-hand side just continued for kilometers downstream. And you can see no riparian vegetation there. So a whole bunch of, the bank sediments just being washed away, probably somewhere downstream, probably currently in the Logan River or Moreton Bay as we speak. This is the more classic photo. This is a classic urban waterway. You can see no riparian vegetation on the sides here, low base flow, pretty low ecological value, etc. Another example, this is at Springfield Lakes again. This is directly downstream of an urban development area. You can see the gully here is just completely eroded out. But yeah, and because of this, we see the riparian vegetation just being completely lost. But we also know fundamentally that riparian vegetation has a whole bunch of other benefits. Shading, reducing, I guess pollution coming in, supplying organic matter for habitat, etc. A whole bunch of benefits. A boring old engineer like me is going to eloquently explain all the benefits of riparian vegetation, but they are extensive. But we lose a lot of those benefits when we lose riparian vegetation because of that change in channel form. And when it comes to channel form, it's likely that the increased frequency of those smaller floods is the key factor, not the big events, the big and frequent events, but the smaller events. So the management implications of this are essentially that we should be doing more to manage those small, frequent rainfall events. Try to mimic a pre-urban environment as best we can. But traditionally, we've done nothing. So what are the water quality impacts, though, associated with urbanisation? So look, pictures of this is saltwater creek on the Gold Coast, highly turbid water, sediment plumes going to rivers and oceans, etc., which has all sorts of impacts. In southeast Queensland, we're losing a lot of our dugong because mud is basically covering their seagrass meadows. Sediment, it's pretty obvious that the key impacts are that increased turbidity. Turbidity being a measure of light penetration through the water column. So, reduced photosynthesis, reduced aquatic growth, biodiversity. Obviously, it looks ugly. It smothers aquatic habitat. It blocks our drainage systems. And then we have all the other impacts associated with the contaminants associated with the sediment. The nutrients, the organic matter, the heavy metals, hydrocarbons, etc. And look, this is a classic example. This is the construction of the J behind Noosa Junction, if you know where that is. Probably about 15 years ago or something. But no, this is a council project, no erosion sediment control. Downstream pipe, this is one of two, about 1,500 millimeter diameter pipes, completely chockers with sediment. So you can see it's not just an ecosystem or a aesthetic issue. It's blocking drainage systems, which obviously causes flooding, etc. Nutrients. A lot of people wonder why are we stopping nutrients into our waterways? The key risk is eutrophication. So nutrients increase, I guess, the risk of algae growth. And algae is a plant. It's probably a good thing. It produces oxygen, et cetera, photosynthesis, et cetera. But the big drama with algae was two things. Number one, when algae dies, the bacteria within the water column eat the algae and subsequently eat a lot of oxygen. And that's when you can often see basically a major decline in oxygen levels in waterways. Also, algae is often toxic. And your photo on the bottom right there is a turtle that's succumbed to red algae off a Florida beach. But yeah, that's probably the main issue associated with elevated nutrient concentrations in waterways. And you see it time and time again. This is Warner Lakes in southeast Queensland with some pretty significant algae issues and subsequently warnings from the public to stay away. Lake Ainsworth, I think, by memory, North New South Wales, again, blue-green algae outbreak. This is Pacific Pines Lake on the Gold Coast, full of algae. And a whole bunch of other urban ponds, waterways, etc., that have had algae issues because of increased concentrations of nutrients. And then you've got a whole bunch of water quality impacts associated with heavy metals. They're generally acute or chronic. Bacteria obviously have disease and death outcomes. And litter, look, I won't talk about this because you've probably seen 1,000 images of turtles with straws up their nose and albatrosses full of plastic, etc. But fundamentally, litter is horrendous to our ecosystems. So the water quality impacts are basically this, toxicity, reduced oxygen levels, disease stress, aesthetics, and blockage of drainage systems. What does that mean to our ecology? It basically is pretty severe and predictable. It's staggering. It is severe and predictable, the ecological impacts associated with our urbanisation. And it's even a term used to describe them called urban stream syndrome. Urban stream syndrome basically has the symptoms I've just talked about: the hydrology changes, the decreased low flow volume, increased frequency of flows, decreased base flow, etc. The eroded, scoured, and sized channels, the poor water quality, and the low ecological values. And this is consistent whether you're looking at a waterway in Paris, Rio de Janeiro, Footscray. Doesn't matter. It's pretty consistent the whole world over. These impacts are severe and predictable. And subsequently, the species that can sort of tolerate these conditions are fairly, it's a far lower diversity, and the species are pretty hardy as a result for the ones that actually do remain. The sensitive ones generally just die, unfortunately. And you're probably thinking right about now, this is a bit of a downer. Brad's, just made me more depressed. It's all bad news. It's not, though, I promise. So what can we do? So I've talked about all the impacts associated with urban stormwater management. And I'm hoping I haven't left you in a state of despair, but rather excitement. In terms of the solutions, what we can actually do, I'm going to leave you in suspense. I'm going to talk about this at our next webinar, which is all about water sensitive urban design, which goes a long way to mitigating the impacts I've talked about today. All the details on how to register on that link, and that'll be held in I think 3 weeks from today. And look, I'm happy to take any questions or whatever. I'm going to stop sharing now, and I'm hopefully, I see there's a whole bunch of questions already come through, which is great. I might try and answer them as best I can now. I'll see if I can share my screen again. Just give me a sec, and see if I can still see the Q&A. So I'll try my best to answer your questions as best I can. But if I missed any, or you want to talk to me separately, just please reach out to me via that email address. So I'm going to go first in best dress, and so I'm going to answer the questions that are in the Q&A. If you put questions in the chat, it'd be really appreciated if you could please put them in the Q&A panel under the Zoom panel. So first question was from Phil Salem, requesting a CPD form. Yeah, Phil, as per at the start, you might have missed it. If you've got a CPD request, please email it to inquiries@oceanprotect.com.au. I'll get that email address up on the screen very shortly. Sean Quilty, some guy called Sean Quilty. Who's that? I'm kidding, because he actually presented the first 3 sessions of this fundamental series. Greetings, Sean. Thanks for dialing in. Sean asks, how can we align with current industry best practices when government policies are over a decade old and certain local government areas still adhere to guidelines dating back to 1999? Yeah, this creates challenges as some developers may scrutinize every detail with legal terms to evade compliance with WSID or storm management systems. Oh, it's a great question. How do I even begin to answer that? Look, I think it's about, look, you could probably do a nice approach. Let's start with a nice approach. Education, liaising with appropriate officials in government, local, state, and federal, to do better. Also reminding them that there are actually legal obligations associated with these, with some of our more recent standards. Like, for example, the state planning policy, that's been around for a very, very long time in Queensland. Similarly, in Victoria, there's I can't remember the term, but there's basically a state-based legislation mandating best practice stormwater quality management and stormwater management in general. Yeah, as Sean and I have spoken separately about a council that I probably won't name, they basically just look at that state planning policy and just ignore it. Yeah, so I think some nice liaison with the council might be warranted. I think it's important to have political leadership for these various government entities as well. So I think if government realised how much value the community put on the health of their waterways, and that was communicated effectively to them, I think they'd actually do more to actually better protect our waterways. Classic example would be plastic pollution. Litter or plastic pollution is one of the key topics of concern for the community. And a lot of government officials, mayors, politicians, etc., don't realise the connection between plastic pollution and stormwater. So I think that would go a long way. Another way, obviously, would just be come out with a big stick and just litigate. And I have seen that effective. Like an example in California, local community groups and environmental groups literally sued Caltrans and one or two other groups for not doing appropriate storm management. And long story short, they've got some very, very lofty goals around what they call total maximum daily loads, including litter. So they basically have to put storm treatment devices everywhere and do more to better protect their waterways. So yeah, start off nicely, but then I reckon some direct action with some heavy hitting class actions and legal action would go a long way. Sorry, I could talk about that all day. I guess I should move on to the next question. So thank you, Sean. Hope that answered your question. Kaylin Murray says, with the increased impervious surface areas being generated, when will it be reasonable to start treating the Q25 as the equivalent to a Q100 or Q50? Oh, yeah. Look, it's really, I think when we start treating the Q25 as the equivalent to, yeah, look, it's a great question. It's beyond probably my pay grade, but I think we fundamentally as an industry know that extreme rainfall events are happening more frequently than our IFD or intensity frequency duration statistics show. Look, I think it's a conversation topic that's well overdue. Most people recognise that Q100 doesn't mean Q100 anymore. So I think it's a conversation that we should be having as an industry. Certainly, I see additional factors of safety. Adding climate change. Increase 20% in intensity with tailwater effects, for example. But I think that's just guessing. I really do. I think far more attention needs to be given on this issue. But Gopal New Pain, Brad, he asks, is there a good practice to manage erosion / washout from the larger development sites during the major event, i.e. 1% or 2% AEP? The control during minor flow is happening, but larger events is always challenging. Yeah, look, it's very difficult. Having said that, not to say it can't be done. So I'll give you an example. A project I worked on I'm sure they wouldn't mind me saying, Aura on the Sunshine Coast, upstream of high ecological value waterway in Bells Creek and Palmerstone Passage. They actually pretty much couldn't discharge any flow during the construction phase off the site at all, even for 1% AEP, because of the sensitivity of the downstream waterway. Now that needs a whole bunch of very fancy erosion sediment control practices, but certainly can be done. Recognizing the critical importance of erosion sediment control, I'd suggest we certainly need to be doing more in terms of more stringent targets, potentially like the targets like I've talked about at Aura. But we can't even get the basics right. As I indicated before from that 2022 Healthy Waterways studies, 40% of sites can't even put up a SED fence properly. I mean, it's just embarrassing. I really think this is just not good enough. Very easy solution is just to go around with the two officers and just start issuing a fine and a very large fine and a stop work order for any construction sites operating illegally. And in the absence of not doing that, I think we're just wasting our breath. So yeah, hopefully that answers your question, Gopal. Ian Everest asks, how do you clean the cartridges? Yeah, pretty simple. It's like a swap, and I think just to clarify, if I show what Ian's talking about, the photo that I was sort of showing before was, I think he's talking about storm filter cartridges. So these are storm filter cartridges we put in the ground, and after generally between 1 to 3 years, we replace the cartridges. So what we basically do, we just basically pull these cartridges out and replace them with new ones. They're basically like the analogy we talk about is like a gas bottle swap and go system. Take old ones out, put new ones in. We take them back to our facilities in Sydney or Melbourne or Loganholme, and we basically repurpose everything. So the components, the hood, the cage, etc., and the filter media itself, which is as per this, is pretty often manky. We can't use that again. So depending on where you are in Australia, it'll either go to landfill or be repurposed in a recycling facility. So hopefully that answers your question, Ian. Ramesh Gimia, apologies if I've mispronounced that. How could we reduce the impact of downstream, mostly erosion, with small regular events? It's pretty simple, actually, Ramesh. We just got to reduce the frequency and volume of flow. Now, that could be rainwater tanks, interception, stormwater harvesting, promoting infiltration. So even in a storm filter environment, we can have some sort of arrangement where we can basically soak water into the underlying ground if the soil conditions permit. So there's a lot of ways we can actually basically reduce the frequency and volume of stormwater runoff being generated and discharged from your site. And obviously, going back a little bit before that, is trying to minimize the generation of runoff. You know, maybe more trees, green roofs, less imperviousness, etc. Porous pavement, whatever. Katie Fletcher from Arup. Greetings, Katie. Yeah. Katie asks, any thoughts on the dirtiest land uses? Oh my God. Is it car parks? Is it residential? Is it roads? It's a great question. Stormwater is highly variable. It'd be very difficult to pick my dirtiest land use, but I think certainly industrial or commercial facilities would be high on the list. Some of the pollution I've seen, you know, to give you an example, I mean, this site, actually this site, for example, this is from a shopping centre car park in Adelaide. So yeah, pretty gross. I can't remember where this ones were from. These are, I think, probably some sort of commercial industrial site. Yeah, so where you've got heavy machinery, some industrial commercial activity, I think that's probably the worst. But certainly roads are terrible. I think roads are just shocking in terms of pollution being generated. And as we've discussed before, Katie, we probably need to be doing a better job of trying to reduce pollutant loads coming from our road projects. So hopefully that answers your question, Katie. Nicola Sainsbury asks, how is the contaminants management cleaning the cartridge? I think I answered that before, so hopefully that answers your question, Nicola. What do you do with the polluted gully pit filters and the longer filters? So I talked about the filters, the gully pits, these ones. I'll just backtrack a little bit. Sorry. These things, we basically just lift the gully pit basket out and empty the contents, and that goes to landfill or whatever. The gully pits themselves are just reused. Sometimes they can get damaged, like particularly with cigarette butts. If there's a lit cigarette butt, they can burn a hole in the gully pit filter bag, but generally they can be used for a fairly long time, again and again and again. Yelena Shrep asks, will you be mentioning the effects of animal agriculture? Oh, Yelena, sorry, she asks, will you be mentioning the effects of animal agriculture and the benefits of plant-based diet as a measure of improving stormwater quality in general? Oh, Yelena, I'd love to, but I probably should keep on track. But thanks for the reminder. Yeah, great way to protect our environment is to shift towards a more plant-rich diet for sure. Thank you, Elena. That's made my day. Jeffrey Harris from Fraser Coast Regional Council says, is there any information on the effectiveness, longevity, and the cost of filter tubes that you showed, quantitatively versus a percentage of contaminants? Oh, yeah. So it might be a conversation we have offline, Jeff, but yeah, look, we've got performance monitoring data for all our key devices, so Stormfilter, OceanGuard, Jellyfish, Filterra. There's about, off the top of my head, about 7 real-world performance monitoring studies for this. And also longevity studies as well. So, for example, Stormfilter, an independent consultant, Renew Solutions, took a whole bunch of our storm filters that have been in the ground for about 2 to 3 years and checked to see if they were still working okay. And the flow rate was consistent with our design treatment flow rate. Long story short, it was, but I can send you a link to that study as well. It's just on our website, oceanprotect.com.au/storm filter under the review paper. But yeah, again, just hit me up if you want to link to that report. What about Phil Salem asks, what about golf courses for generating pollutants? Yeah, look, it's an interesting space. I've had a few chats with various golf course operators in the past and about this issue. And some golf course managers will say, "Oh, look, no golf course manager would use any excessive nutrients because it just basically costs them money, and they definitely don't want to, have nutrients leaving their site. So they do try and recycle a lot of water within their own sort of boundary." But I think I'd be particularly concerned around pesticide application on golf courses. One emerging contaminant I didn't talk about today, when I say emerging, it's been around for a long time, is pesticides. And I think that is a key pollutant that does not get enough attention. And it's being used in enormous quantities in our urban environments and draining into our urban waterways. Just literally 2 days ago, there was a study of frogs around New South Wales. And I think they're going to do one, or they have done one, but haven't published it on cane toads and frogs around southeast Queensland, but indicating maybe that the frogs and other ecology are basically dying as a direct result of pesticide contamination in our urban waterways obviously from pesticides being used in the urban environment. Rob Booker might be able to give you something. Here's the next question. I know council are a major user of pesticides, so might be worthwhile having a chat to councils about that. Rob Booker, greetings, Rob. Rob from Sunshine Coast Regional Council. Rob says, thoughts on pollution from flood flows compared to stormwater. Are you familiar with a recent UQ study done at Moreton Bay, looking at mud in the bay primarily from flooding? Yes, I am. I'm actually looking to do a podcast chat with the study author. So I am familiar with it, but yes, certainly both are, look, in summary, both are pretty bad, obviously. So stormwater gets a lot of attention, and rightfully so, because the vast majority of pollutant loads are carried in those small frequent flow events. That's why we often try and target those in particular. But that's not to diminish the importance and the damage caused by flooding. And I think back to the recent flood events in Brisbane, where we saw, cars and fridges and pontoons floating down the Brisbane River. Yeah, we can try our best to stop microplastics and sediment and Coke cans and bottles, but obviously those bigger pollutants, and when I say pollutants like cars and fridges and whatever, they're a massive problem. And I remember doing a beach clean over at Moreton Island with Sea Shepherd, and this is after the floods, and polystyrene was everywhere on Moreton. Sorry, not Moreton Island. It was I can't think of the island. Mind blank. The island off Brisbane. It was like 70K off Brisbane, and it was just covered in microplastics. It was staggering. So yeah, look, I don't want to diminish the importance of flood flows in any way, but certainly both are really potentially damaging if they're not managed appropriately. And there's a lot of things you can do to obviously minimize the damage of flood water quality issues as well, particularly in relation to, I guess, your upper reaches of your catchment in terms of promoting a lot of stream bank vegetation, etc. But obviously trying to if we take anything away from the Brisbane floods, it's not to have pontoons made of polystyrene and styrofoam. I think that's just crazy. Sorry, Rob, I hope that answers your question. Matthew Kirby asks, is there any benefit treating stormwater to remove nitrogen and phosphorus if the water will be discharging to farming land with little ecological value? Yeah, look, it is a grey area. Obviously, you want to pick your battles, I guess, in life in general, but I don't think just because something is already degraded doesn't mean you just sort of just walk away and don't do at least what is considered minimum best practice standards. I think the targets that we have in the salmon industry in relation to water quality are bare minimum, 80, 60, 45 or thereabouts. that's reasonably easy to achieve. And I'd like to think in time that we'd do more to improve the practices on agricultural land as well. As Elena indicated, maybe we'll all go plant-based and won't have as big a problem with agricultural land. But that's another story. But I just don't buy the fact that you can get away with doing bad water quality management just because the waterway is getting hammered by someone else. Hopefully that answers your question, Matthew. Happy to have a discussion about that though. Stratty, thank you, Kylie. Yeah. Yeah, Sea Shepherd. Yeah, sorry. I did get, thank you, Kylie. Greetings from Mackay City Council. Uh, Public awareness. Sorry, this question from Janatul Ferdouche. Public awareness is important. How to increase awareness effectively in day-to-day life? Oh, it's a great question. I think, and I don't want to do a shameless plug to the Ocean Protect podcast because I always do it, but look, I think as a stormwater industry, we're really good at talking to stormwater engineers and other stormwater professionals. I don't think we do enough to talk to Joe Public. One of the reasons we did the podcast, the Ocean Protect podcast, is to reach Joe Public and to get them thinking about the importance of stormwater in their day-to-day life and in relation to the health of our waterways in particular. I'm always amazed. I often get people just from non-stormwater people telling me that after listening to the podcast episodes, particularly in relation to litter and plastic pollution, that they spend their days with their head, eyeballing the footpaths and road pavements, looking for and picking up litter. Because they know that if they don't, it'll wash into their waterways because of stormwater. So I think certainly public education can be done a lot better. And it's not stormwater events, it's not webinars, it's reaching Joe Public where they are. Most people are digesting their content on their phones, whether it be a podcast or social media reels. And I think more stormwater professionals need to be doing that in particular. So I know it's a bit of an unusual thing for a stormwater professional to get on TikTok or Instagram or whatever, but I think maybe we should be doing that. And certainly, there's certain opportunities to increase media attention on this issue as well, whether it be writing opinion pieces for news outlets, approaching, TV, etc. It certainly has worked for other, I guess, subject matters. So I don't see why it wouldn't be effective for stormwater. But certainly these webinars are certainly popular. I mean, we had like 640 registrations. I think we had about 400 turn up today, and we get a lot of people watching it live. So feel free to share the content or whatever you want to do, or just tell your friends to think more about stormwater. I know there's a whole bunch of questions in the comment in the chat, so I'm just going to get to those now. Question from Bo Reichard from Brisbane City Council. Great, it's great to see you dialing in again, Bo, and I'm sure a lot of your colleagues as well. This is a great question, Bo. Why aren't centrifugal separators utilised as a coarse separator before filter? This would be better for maintenance to remove particulate, for filter longevity, larger particles, and also attract micro contaminants. So when Bo's talking about separators, like centrifugal separators, he's talking about like often like continuous deflecting separation units, like CDS type technologies. Full disclosure, I'm just trying to find a picture of it. Ocean Protect do our own version of that centrifugal sort of type of GPT. I'm just trying to find a picture. Sorry, I'll find it somewhere. Apologies, everywhere if everyone's losing their mind. I won't try and find it. But look, so should we have pre-treatment upstream of filters? Absolutely. So for our storm filters, for our jellyfish, etc., we always recommend some sort of pre-treatment upstream. But I'd also suggest we should be doing pre-treatment upstream of vegetated systems as well, particularly wetlands and bioretention systems or big bioretention systems. And I'm always staggered that this isn't standard practice. We do a podcast. We're releasing a podcast with Murray Powell about this topic exactly on Monday. And to quote Murray, he says, anyone who doesn't use GPTs upstream of a wetland is an idiot. And I think we should be certainly going back to first principles when it comes to stormwater treatment and thinking more about a stormwater treatment train as opposed to reliant on a single device like a bioretention system. thinking that it would just magically remove all pollution and still work fine. Cool. Thanks for the question, though, Bo. Hopefully that answered your question. Mohammed asks, how can we control carbon footprint in urban stormwater management? Is there any more efficient method rather than traditional methods? Yeah, look, certainly minimizing the use of concrete will go a long way. Certainly reducing, I guess, the componentry of devices will go again further. But fundamentally, stormwater treatment devices, their primary purpose is water quality or stormwater management, and they should be working. Not to diminish the importance of minimizing carbon footprints, but these devices or general practices should be fit for purpose, and they are there to protect the health of our waterways. And I think the primary focus should be on making sure that they are working appropriately. Having said that, yeah, if we can minimize their energy intensiveness or make sure that their components or materials is from sustainable sources, that obviously is critically important as well. So, like, give an example, and I don't think it's that difficult. Like, for example, our recent Ocean Guard, our gully pit inserts, they're made 90% of the mass of that is made from plastic waste. So that was a change that we made as a company just recently. So it's a far more sustainable product, lower carbon footprint, and it's also lighter, really strong, and cheaper. So it's actually a real positive. So just because something's got a low carbon or environmental footprint doesn't actually mean it's going to be worse. In fact, it probably means it's going to be better fit for purpose. Great questions, though. Yeah, so question from colleague Kylie from Mackay, regulated waste for some of those industrial road waste. Yeah, so the GPTs, the waste is generally transferred to some sort of landfill facility. Obviously, if it's super contaminated, it might go to a different facility. Hopefully that answers everyone's question. I think no, I've got Thomas Steinfeld asks, in your experience, are councils now being proactive about where they are designing and planning for any playgrounds or any asset with potential to produce microplastics in relation to stormwater? Yeah, look, I'm not sure. I think your question's in relation to the fact that playground matting or the soft sort of surface of playgrounds is often made from recycled car tires, which are full of microplastics. And OzMaps and Kangaroo Blue have recently done an assessment showing that playgrounds where this stuff's used are a major source of microplastics. So I think hopefully that councils are getting their head around the fact that that shouldn't be done. But look, I might have to, if you've got any further questions from today, I'll just get up my, if I can, I'll get up my contact details as well. But again, just a reminder, and I'll get up that email address. I did promise it before. If you do have any CPD form requests, if you can email them directly to inquiries@oceanprotect.com.au. So yeah, again, if you want a CPD for attending today, please just email that address there, and I'm sure you'll get a CPD form sometime soon after. Might take a little bit of time, but because we do often get a bit of a backlog of these requests, but first in, best dressed, basically. If there's no further questions, I might pull up stumps for the day. Thank you so much for everyone who's dialed in today. It's really appreciated. I know I've gone over time already, but I'll let you guys get back to work. But if you have any further questions or anything, and if you'd like to reach out and ask me anything else, I'll put my contact details on the screen. But again, just a reminder that if you're keen to come along to our next webinar, it's in 3 weeks' time from today. All the details are at oceanprotect.com.au. So if there's nothing further to add, I'll look forward to hopefully catching you guys at the next webinar or at an event or somewhere else face-to-face sometime soon. So thanks very much, and I'll enjoy the rest of your day.